I'm here with Michael McNamara, Vice President and General Manager of the System Software Group at Cadence, and one of the authors of the TLM-driven Design and Verification Methodology book. Hi, Mac. Thanks for being a part of creating this book. I want to ask you a few questions. Let's start with what you think is your favorite part of the book.
Well, I don't know. The overall book is a way to capture the thoughts that this team of people that you see on the title here have been sharing with one another, refining with customers, partners, the industry really on how we can move design and verification up from where it's been at the register transfer level to a new, more productive abstraction level that lets us talk about transactions between blocks of logic that implement things and model at a higher level so we can implement things more quickly, verify them more quickly. It's all about time. And, do that in this decade, right? So it's a big transition. It has to be well thought out. We put together a lot of our thoughts in this book, and we hope you enjoy reading them.
So you talk there about a lot of new conversations and new ideas. What's the impact on the industry that you expect in the short term, in the two-year window?
Well, I expect people to pick up this book. There's some things in it that they're doing already that they haven't recognized, but they have been trying to verify things before committing to silicon, before committing to RTL. We put together a flow here that captures these various efforts that people have been employing to reduce the complexity, the time to market, and put them into a solid, well thought out flow that ties them all together in a way that they're going to get a lot of productivity in a short amount of time, doing things that are really just a small step up from what people have been doing today. But it's a coherent assemblage of all of these ideas into a single book that addresses the real problem that's been holding back our productivity.
You talk about time to market, but transactions are a big change from the concepts of RTL. Talk about that.
They are a big change, and they're one that's the change that we've needed to implement for a while. We've been burying our Verilog VHDL coders in a thankless task, really, of implementing all of the small steps that complete a transaction. And we haven't been setting our goal at the transaction itself. We've been describing I'm a state machine designer, or I'm a phase lock loop designer, or and no, you shouldn't be doing those things. You should be leaving those for a tool, and you should be focusing on the overall task before us, which is to deliver some sort of service in an automated way in software and hardware that is going to be reliable, that's going to be very small in area, that's going to give us the kind of performance that we need for the end application, and not too much performance. I mean, one of the ways we suck down battery life is we over-engineer things to deliver performance that can't be realized because the upstream bit is not producing data fast enough to be consumed, or the downstream can't accept the pixels as fast as this intermediate engine is producing them. If we can right-size the overall design by focusing on the overall interaction between the blocks, the transactions between them, then we can size everything so that we have the most efficient implementation that delivers all the performance you need using as little power as possible.
So you strike me as someone that finds the fun in everything you do. What about the book was your favorite part of the book, or the most fun about the project?
Well, I mean, really getting the ideas together from a whole set of people that have been looking at different parts of the problem from their own perspective, and allowing all of us to capture our unique ideas and put them into a single flow, and then read back through all of that and say, oh yeah, now I have finally understood what Stuart meant when he was talking about X, Y, and Z, and what Mike meant when he was talking about RS and T, right? So as we stitch the whole thing together, reading back through it, a real coherent sense emerges of what the problem is, what are some of the ways to attack the problem, and then the value of the overall solution that we end up describing together in a way that we hope is really accessible to the reader.
Great, Mike. Mac, thanks for being with us today and sharing the book and your time.
Thank you very much.